Okay, in this lesson, we're going to be solving by factoring these polynomial equations. And so when you're solving, you're going to see equal signs, and you're going to actually be solving for what the variable equals. And so in the case of number 1, anytime we factor, look for a GCF first. And so in this case, we can divide both terms by a 2. And so I'm going to factor that GCF out, and that's going to leave y to the 4th minus 9. Now, when you're solving an equation, if the GCF doesn't have a variable, it's not going to lead to a solution. And so technically you can ignore it. And so if we divide both sides by the 2, we end up with y to the 4th minus 9 equals 0. 0 divided by anything will still be 0. So that just simplifies things for us. And then y to the 4th minus 9, we could rewrite this as a difference of squares. Y to the 4th is y squared. We would end up multiplying those. And then 9 is the same as 3 squared. And so one of our factors is going to be y squared minus 3. The other factor is going to be y squared plus the 3. And now all of this still has the equal sign. All of it still equals 0. And so once we have our factors, see if you can factor even more. This quadratic, this is not a perfect square, and so we can't factor the first quadratic. And this plus sign and this 3 mess us up for being a difference of squares on the second factor. So from here, we just need to set each factor equal to 0 to solve for y. In both cases, we're dealing with a quadratic equation that doesn't have a center term. And so the best way to solve these is to isolate the squared term. In this case, we're going to add 3 to both sides. And then we're going to use the square root property. And so if y squared equals 3, that means y equals the positive or negative square root of 3. This radical can't be simplified, and so this would be our simplified final answer. In the case of the red equation, we need to subtract 3 from both sides. And then using our square root property. And then we do need to simplify this radical. There's a negative under the radical, and so that means this is imaginary. And so we just take an I outside of the radical and leave the 3 under the radical. And so we are dealing with a degree 4 polynomial here. And so anytime you're dealing with a degree 4 polynomial, you should end up with 4 solutions. And so our 4 solutions are positive and negative square root of 3, that's 2. And then positive, negative I square roots of 3, that's 2 more solutions. So those are our 4 solutions, and that would be our final answer. Okay, for number 2, we're also dealing with a degree 4, and so we're looking for 4 solutions here as well. And so to factor this, look for a GCF first. 6, 27, and 15 can all be divided by 3. And so if you want to think of this step as just dividing both sides by 3, you can. We can go ahead and get rid of that. And so we have 2a to the 4th plus 9a squared minus 5 equals 0. Again, if this just said factor completely and we weren't actually solving, we would need to keep track of that 3. But when we're solving, we don't care about the 3. Okay, and so here we're dealing with a degree 4 trinomial. There's 3 terms, and so we can factor it like we would a quadratic if we let the variable u equal a squared, because then u squared would be a to the 4th. And so I can replace the a to the 4th with a u squared. And we can replace a squared with just u. And so now we factor this just like we would any other trinomial. A times c is negative 10 So I need two numbers that multiply to negative 10, but add to the middle number 9. So in this case, those numbers are negative 1 and positive 10. And so we split the middle with those numbers. I'm going to put the minus 1 first. Doesn't matter which order. And then the plus 10. Still using the variable u. And so out of the first pair, we can divide both by a u, leaving 2u minus 1. Out of the second pair, we can divide both by a 5, leaving 2u minus 1. The 2u minus 1 matches, so that's one of our factors. Then the other factor comes from the u, and that's a positive 5, and so u plus 5. Still equals 0. And so now we're ready to bring the a squareds back. And so replacing u with the original a squareds. Neither of these quadratics are factorable. So just like the last example, we're going to go ahead and set each factor equal to 0 and solve. And so when we set the left side equal to 0 and solve, the first thing we would do is add 1 to both sides. And then divide by the 2. We're isolating the squared term. Anything that's not a part of the square has to go. And so now we're ready for the square root property. And so in this case, we have the positive or negative square root of 1/2. And so to simplify the square root of a fraction, you break the square root up from the numerator and the denominator. And so square root of 1 is just 1. And then square root of 2 is not a perfect square. And so now we need to rationalize the denominator. To do that, we multiply top and bottom by that square root of 2. And so then the top becomes square root of 2, the bottom becomes square root of 4, which is a perfect square. And so we get square root of 2 over 2. And so our final answer for this side would be positive negative square root of 2 over 2. On the right side, we subtract 5 from both sides. And then when we take the square root, all we have to do is take an I outside the radical. And that would be our final answer there. And so our 4 solutions is the positive and negative square root of 2 over 2. That's 2 of our solutions. And then positive, negative, I square roots of 5 would be the other 2. Looking at number 3, there's 4 terms here. Anytime you have 4 terms, go ahead and split it right down the middle and try to factor by grouping. And so out of the first pair, I can divide out an x squared. And that leaves an x minus 3. Out of the second pair, I can divide, the leader is negative, and then we can also get a 4. Or actually, we can get a 16. And that leaves an x minus 3. The x minus 3 matches. That means that's one of our factors. And then the other factor is x squared minus 16. Just collecting the outside in order. And so this quadratic is actually a difference of squares. Square root of x squared is x. Square root of 16 is 4. And so that factors to x minus 4x plus 4. And so it's really nice when we can get to all linear factors. It makes it really easy to solve. So all of this still equals 0. And then when we set our factors equal to 0, we get x equals positive 3, x equals positive 4, and x equals negative 4. And so we end up with 3 solutions here, which we should have gotten because this is a degree 3 polynomial. So 3 solutions. For this last one, I see a GCF right off the bat. We can divide both of these by 5, and then they also both have an x. And so 5x would be one of our factors, and we don't want to ignore that because there was a variable. Everywhere you have an x, you're going to have a solution, so we don't want to ignore that 5x. And then inside the parentheses, we're left with just x cubed, and then 5x over 5x is 1. And so this x cubed plus 1, that's a sum of cubes. X cubed is a perfect cube, and then 1 cubed would give us the 1, so that's also a perfect cube that a lot of people forget about. And so x is our a value, and 1 is our b value for this sum of cubes. And to factor a sum of cubes, you're going to have a binomial times a trinomial. And the signs are going to be the same as the original, so plus, opposite, and then always plus. Okay, and then we're going to fill in these with a, b, a squared, b squared, ab. And so a in this case is the x, b is 1, a squared would be x squared, b squared would be 1 squared, which is 1, and then a times b would x times 1, which is just an x. Okay, and so we still have that 5x from the GCF. And this quadratic that you're left with, this trinomial, looks like it's going to be factorable, but it's always going to be prime. Okay, and so remember, all of this still equals 0, so we have to set each of these 3 factors equal to 0 to solve. Okay, and so I'm going to come to the side. We're going to have 5x equals 0, which is just linear. Divide both sides by 5, you get x equals 0. That is one of our 4 solutions. Okay, and our other solution is going to come from the x plus 1 equals 0. So we've taken care of the 5x. Now we're looking at the x plus 1. We would subtract 1 from both sides and get x equals -1. That's solution number 2. We're looking for 2 more. And so this last one's going to be the hardest one. This quadratic is not factorable, and so we have to solve it by either completing the square or quadratic formula. And so I'm going to use the quadratic formula. Okay, so we have x squared minus x plus 1 equals 0. Our a value is 1, b value is -1, our c value is 1. So quadratic formula says x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And so filling in those numbers, -b would be +1, plus or minus b squared would be +1, minus 4ac all over 2 times a. And so that gives us 1 plus or minus the square root of 1 minus 4, which is -3, all over 2. And so the last thing we need to do here is just take an I outside of the radical, and you can leave your final answer like this. And so this would be our 2 remaining solutions. One is from the 1 plus, the other is from the 1 minus. And so our solution set has a 0, a -1, and then the 1 plus or minus I square roots of 3 over 2.